what's going on, everybody? So, we are moving into Unit 11, Lesson 2, Page 2. So, just going back, showing you guys that first page again like I normally do. I hope everybody's doing great. Hey, what's going on, Tabitha? Big thing we're going to really focus on today are those two things I have highlighted right here. The 45-45-90 triangles and the 30-60-90 triangles, because that's going to be really important for the lesson that we're going to be going into on Monday. And just to mention it once again, I have said it in the past, Fridays we are no longer doing lessons, so I will still have my Zoom available tomorrow, but tomorrow is like a work day for you guys to catch up. Okay. Nice. Was it a cool shirt, Shannon? One of my wife's students said that she's going to make us some. I was hoping somebody was going to make me a Spider-Man mask. We will soon find out. Let's see here. 3, 6, 7. It says I got 9 people in here. All right. So I am most likely just going to go with it today. Yeah, I'm just going to go into it. I think we got quite a few people in here already. Yeah, I'm just going to start going. All right, so yesterday we talked a little bit about those special right triangles that you guys were introduced to back in geometry with Miss Randolph. And I'm just going to kind of extend on where those special right triangles came from using something known as the unit circle. So I'm going to start off right in the first quadrant and show you guys that every single thing that we're going to be doing is going to be indeed a special right triangle. So I'm going to color code this because it's going to make it a little bit easier to understand the entire circle as a whole if we were to do so. So what I'm going to do is I am going to draw my first line to that 30 degrees, both the initial and terminating rays, and then I'm going to create the right triangle similar to what we had yesterday. So there's a little right triangle right here. And this angle that's on the inside is going to be 30 degrees. And it's 30 degrees because it tells us that this line up here was 30 degrees. Okay? So if this is 30 and this is 90, then we just have to find the missing side. So again, there's something called a special right triangle. We did it on the front page. If one angle is 30 and the other angle is 90, that means the final angle has to be 60. So I'm just going to put 60 in there. And now that I know that I have 30, 60, 90, I can label in the remaining sides based on the special right triangle we had above. So across from the 30 degree angle, I'm going to zoom out a little bit so I can show you guys that across from that 30 degree angle is 1/2. So if I come down here, across from that 30 degree angle, it's 1/2. Across from the 60 degree angle, it says that it is radical 3/2. And across from the 90 degree angle is 1 because we're working with a unit circle. So the hypotenuse should always be 1 all the way around. So every one of these lines that we have in the circle will always be 1. Okay? So that's all I did. I just wanted to show you guys how to find those angles, how to find those sides. So I'm just going to do the same thing for the next triangle. And we're not going to do this for every single one. I'm going to only do it for a couple because I'm going to show you guys there's a trick for finding all of them. So now what I'm going to do is I'm just looking at the next triangle at 45 degrees. So again, it's 90 in that bottom right corner. this angle over here, that entire angle is going to be 45. So if that's 45 and this is 90, that means if we look at that special right triangle on the first page, this other angle is going to be 45 as well. So this is the special right triangle 45, 45, 90. So all these triangles that you guys were given last year came from this thing called a unit circle. Okay, so just like before, the unit circle, the triangle for 45, 45, 90, all the angles I gave you guys yesterday. So eventually you guys will have to have all of these lines memorized, but there's a trick for it, and I'm going to go into detail when we start actually doing the trig. We're not actually doing any sine, cosine, or tangent today, but that's what we'll start up on Monday next week. So in this case, across from the 45s is, it was over here, 1 over radical 2. And one thing that we didn't do that we should have last time is, even though they're both 1 over radical 2, those fractions are not rationalized. We're not allowed to have square roots in the denominator of a fraction. So if we want to solve this, what we want to do is derationalize it. And you guys may remember this from geometry. We did a little bit of it earlier this year. But to rationalize a fraction with a radical on the bottom, you just have to multiply both top and bottom by that radical. And both these fractions are exactly the same. I don't know why I put an equal sign in. I was supposed to put a multiplication sign in. So if we multiply both top and bottom by radical 2, we'll have radical 2 over radical 4, which really can just be simplified to radical 2 over 2. And that would be the same thing up here. I'm just not going to show all the work. It's just radical 2 over 2. Okay? So now when I come back down to this picture, I now know the angles that are across from the 45 degrees is going to be radical 2 over 2. Across from the 45 degrees is radical 2 over 2. And once again, the hypotenuse is always 1. Okay? So I'm only going to do one more triangle because I'm hoping you guys are going to notice that we actually have all the same triangles across the board. So the last one I'm going to do is this one, which is going to be at 60 degrees. So this whole thing is 60 degrees. And I know it's all overlapping and it can get confusing. That's why I'm trying to color code it and try to show it to you guys the best I can. So that whole thing's 60 degrees. So now we're back to a 30, 60, 90 triangle. So the 90 is still in that bottom right corner, but this time the 30 is going to be up top. We said before, across from the 30 degrees is the 1/2. So 1/2 is going to be down here at the bottom. The hypotenuse is always going to be 1. And then that last side is going to be radical 3 over 2. Now I'm going to try to represent this the best I can doing this over the internet, because if we were in class I could show you guys folding and I could show you guys reflections. But what I want you guys to notice, if we look at our blue triangle right now, so the first triangle that I drew, if I reflect that over the y-axis, I'm going to reflect it right over the y-axis, and you guys should notice that this triangle is going to be exactly the same, but flipped over. Sierra, just kind of go with it right now. Once I start doing some more with it, it's going to start making sense. This is something brand new. You guys shouldn't understand this your first time through. You just got to be patient with it. So what I want you guys to look at is this blue triangle right here has now just been flipped over the y-axis. So this says it's 30 degrees, but this one over here says it's 150 degrees. They're really going to be the same triangle because we're not looking at the overall angles, we're looking at the inside angle. And yesterday and the day before, we called those reference angles. So reference angles are going to be really important for finding the missing sides of a triangle. So right now, I haven't solved any type of problems with you guys. All I'm doing is I'm just copying down the triangles that you guys learned in the past. We haven't done any solving. We haven't done any math. We're just copying down those triangles. So it is flipped over. It is 30 degrees. So that means this is a 30, 60, 90 triangle. Well, if we have a 30, 60, 90 triangle, that means all the sides are just like they were before. Across from the 30 degrees is going to be 1/2. Across from the 60 degrees is going to be radical 3/2. And the hypotenuse is going to be 1. There's just a really, really simplistic difference between these two sides. Since we are in the second quadrant, we went left. If we go left on the x-axis, that means that that value cannot be positive. It's going to be negative. If I go up, it's still going to be positive, because if you go up on the y-axis, that is still going to be a positive number. So depending on what quadrant you guys are in, it can change the overall positive or negativity of those sides. Okay? So I know this is confusing, and a lot of you guys are going to get lost, but it's because it's an introduction to what we're going to be doing on Monday. So let me scroll down to the bottom, and let's look at something separate so it's off the circle. So maybe it might make a little bit more sense if we do it that way. So the first thing I'm going to have you guys do is I'm going to look at A. All right. So part A is 120 degrees. So what I'm going to do is I'm just going to draw, but why isn't the other one negative? Because, Shannon, the other one was going up. So if you think of a grid, if you're going left on the grid, it's negative everything over here. But if you go up, everything is positive. So this is saying I went left -3, or negative radical 3/2, and then I went up 1/2. So that has to be positive. Now, if I went down, then it would be negative. So down here, I'm going to draw an x and y axis. And I'm going to draw in 120 degrees, just like we were supposed to do on the homework from lesson number 1. So 120 degrees is going to be over in quadrant 2. So I'm just going to draw that angle for 120 degrees. Now, the whole purpose of us doing this is we're trying to find the coordinate of the terminating ray. So the coordinate for this terminating ray is way up here. It's where that arrow is pointing. We're trying to figure out what the x value is and what's the y value. So in order to do that, what we're going to do is locate the reference angle and then write in all the missing sides based on the special right triangles that we've been doing since geometry. So now I'm going to draw in my right triangle. So I have my right triangle. Well, the whole outside is 120 degrees. So we said the outside portion of this is 120 right here. We need to figure out the inside of this. Well, if the entire outside is 120 degrees, and we know that a straight line is 180, because this whole line all the way across would be 180 degrees, that means we have to subtract them to find that inside portion. So if we do 180 minus 120, that's going to give us an inside angle of 60 degrees. So that's where that's coming from. So just like we did before, we know one part's 90, one part's 60. So that means this has to be a 30, 60, 90 triangle. So as of right now, you guys have notes. You guys have your homework that's going to revolve around these two triangles that we talked about yesterday, because it's just going to be this on repeat. So our 30, 60, 90 triangle is over here on the right side. So all I'm looking for you guys to do is write in the missing sides in the correct positions. So I'm coming back down here. So across from the 30 degrees, it's 1/2. Across from the 60 degrees, it's radical 3/2. And the hypotenuse is always 1. So all those triangles that we're going to be doing is coming from the bottom of that first page. This is what your homework assignment looks like. It's just like this. It's all the same steps that I just did. Now, if I want to find the coordinate, I need to know the x value and I need to know the y value. Well, the x value is the number that we use to go sideways. So if I start here at the origin and I go sideways, we're saying that we went over to the left 1/2. But we also have to remember, because we're going to the left, that 1/2 is going to be negative. So the x value for this triangle is going to be negative 1/2. Well, now I need to know the y value. So this is showing that we went over to the left negative 1/2, and then we went up radical 3/2. So for this triangle, we found the coordinate that would lie on the unit circle. So the unit circle is not always going to be perfect numbers. They're going to be fractions like what we have right here. Okay. So I'll walk through another one step by step, because your homework is going to look just like this. Just like it. Okay. So I'm going to do all of the bottom 4 questions with you guys, rather than looking at the big picture, because I think the big picture is going to be too confusing if we keep looking at it that way. All right, so I'm going to go over to part B now. So this time we have 210 degrees. Well, 210 degrees is going to fall in the 3rd quadrant this time. So we have the initial, and then we have the terminating ray way down here. So all the way around is 210 degrees. But in order to find the coordinate down here, we have to create the right triangle and find the reference angle. So I'm going to create my right triangle. So I'm going straight up. I have my right angle. Now here's the thing. We are just looking to find this little piece down here. So if it's 210 degrees all the way around, we have to figure out what that little acute angle is going to be. Well, if we know that's 210 and this is 180, in order to find that little angle, we just have to subtract them. So if we do 210 minus 180, that means that this little angle right here is going to be 30 degrees. So now we're using that special right triangle just like we did in the last problem, just like we've been doing in all the problems. If that's 30, that's 90, that means this has to be 60. So again, we have a special right triangle, which is 30, 60, 90. So I'm going to just look at the one on the left here. If I look across from the 30 degrees, we said that across from 30 is 1/2. Okay. So right now, you guys don't have to memorize it, because what you'll be able to do is just look at your homework, or I'm sorry, look at the lesson for your homework. In the future, I'm going to show you guys a shortcut at getting this answer every single time. Okay? But that's working with the trig. So some of you guys may not find that as a shortcut, but in math, it is a shortcut. So across from the 30, it's going to be 1/2. I'll do it in red because I'm color coding. Across from the 60 degrees, again, if I look at the previous picture, across from that angle of 360 is coming up here to radical 3/2. And then the hypotenuse is always 1. So we want to, oh, I always hit that arrow. We want to find the coordinate. So in order to identify the coordinate, we just have to say what the x value and the y value is. So I'm going to start back at the origin, and I'm going to the left. So I'm going to the left, radical 3/2. Because we went left, that is negative radical 3/2. After we went left, we are also going down. And this is showing we're going down 1/2. So since we're going down, that's also going to be negative in this case. So the coordinate to this triangle, to this angle that we created, would be negative radical 3/2, comma negative 1/2. Okay. I hope you guys are kind of feeling okay. Because we're adding on to the previous lesson. So what we did is we drew our angle, we found the reference angle, and then after we find the reference angle, we just have to decide which triangle we're using. So C and D are the same types of problems. There's just one slight extra step, because if you recall what I said in the lesson the other day, when we graph angles, we only want to graph angles that are in between 0 and 360. And if you guys look at C and D, they're not between 0 and 360. So we just have to make sure we change it so they are. So Tessa, those fractions, I gave them to you guys on the first page. So this was from the lesson yesterday. If you guys recall, and I mean, you may have to go back to the video and watch how I got the triangles yesterday, but if you guys recall from last year, Miss Randolph taught you guys some special right triangles. One was 45, 45, 90, which you guys learned as 1, 1, radical 2. And if you don't remember it from last year, it's okay. But that's what was introduced to you guys last year. We're going to go more into those triangles within the next couple of lessons. The other triangle that you guys were given was the 30, 60, 90 triangle. And when you have a 30, 60, 90 triangle, that is represented by 1, radical 3, 2. So because we're working with something called the unit circle, what we had to do is change the hypotenuse so they were 1. So if you go back and watch the video from yesterday, you'll see how I got what I highlighted above. You'll see what I got when I highlighted the pink and the red. But these are the two triangles that we're basing it on. This is what you guys were introduced to last year, and we're just expanding on it when we're going into the trigonometry this year. Okay? So hopefully that answered your question. I'm going to jump down to part C. So Ella, I see that you said you're still a little confused, but maybe if we do a couple more practice ones, it'll start coming to you a little bit easier. So if you look at C, we're at 495. So again, that's not between 0 and 360, so we have to make it so it is. So you just have to decide if you're adding 360 or subtracting. I hope you guys understand that if you subtract 360, it should fall between 0 and 360. We don't want to add on to it. So I'm going to subtract it off, and if I do so, I'm going to be at 135 degrees. So 135 degrees, that's going to be in quadrant dos. So I got my x and y axis again. So that one line is so crooked. I got my initial ray, which I guess I'm not color coding anymore. I'm going green this time. And we said we're going into quadrant 2, which is at 135. So that's 135 degrees. But what we need to do now is find the reference angle, because what we're trying to do is find the right triangle so we can find the coordinate point of where that line is pointing to. So I'm going to create that triangle. So we have to find this angle right here. So in order to find that angle, again, we know this is 180 degrees. So if that's 180 degrees, we just have to subtract the 180 by the 135 that we were given. If we subtract those, we're going to get 45 degrees. Well, if that's 45 degrees, then we know we have our special right triangle of 45, 45, 90. So 45, 45, 90. I'm going to go back to this previous page. It's represented, and I shouldn't be highlighting these ones anymore. I should be highlighting the rationalized ones. 45, 45, 90 is represented by those three numbers. So across from the 45s, they're going to be radical 2 over 2. And the hypotenuse is always the easy part, because the hypotenuse is always going to be 1 no matter what. So I know this is 1. Across from the 45 is going to be radical 2 over 2. And across from the other 45, it's radical 2 over 2. So I'm just asking you guys to tell me the coordinate again. Now that we know all the sides of the triangle, I just have to state the x and y values. So in this case, I'm going to the left radical 2 over 2. So because I'm going left, it has to be negative. And in the last part, we're going left and then up. So since we're going up, that's positive. So it's just going to stay radical 2 over 2. It'll definitely take a little bit of practice with these. And if you guys haven't already done so, if you look at the homework, I did 9 separate questions like these. So I didn't want to give you a lot. I hope that's not considered a lot for you guys. Because if you're looking at the work that I'm doing, as long as you know all the sides of the triangles, you'll be okay at solving these ones out. So I'll finish off on this last one. And then I'm going to jump on the homework just to write something down for you guys. So before I can draw my x and y axis, you guys should recognize this is negative 150. And once again, it has to fall between 0 and 360. So we don't want it to be negative. So what I'm going to do is I'm going to add 360 onto it. And if we're adding 360 onto that negative 150, we're going to get 210 degrees. Okay, so now that we got that 210, we can graph it. Come on, straighten for me. No, you don't want to straighten? Oh, it's because my iPad froze again. That's great. So I got my x and y axis. This time it's 210, so that means we're going all the way to the third quadrant. So didn't we do 210 earlier? So what you guys should notice is this is actually the same exact thing as part B, because we're graphing the same exact angle. Sierra, radical 2 over 2 is the rationalized form, because you're not allowed to have square roots on the bottom of a fraction. So we did, in order to get rid of the radical 2 on the bottom right here, You have to multiply it by itself. That's something that you guys were introduced to in geometry, and then we did a little bit more of it when we did radicals earlier this year. So if you multiply it by itself, radical 2 times radical 2 is radical 4, which just becomes 2. Yep. So honestly, I don't even have to do D, because what I hope you guys are seeing, and this is based on that new vocabulary word that we did yesterday, that 210 and negative 150, these are called coterminal angles. And we said yesterday that coterminal angles just mean that they share the same ray. So everything that we put down here for part B is actually the same exact answer for part D. There's no purpose in me writing it all over again because it's going to give you the same exact answer. Okay? So, my recommendation for you guys on the homework for this, which I am not, that was the homework from yesterday. On the homework for number 2, for 1, I'm not even putting the due date until Monday. I'm putting Monday at 9 p.m. So you have tomorrow, you have the weekend, you even have Monday to come during the Zoom hours and ask me questions. It says that we have to draw the diagrams and find the ordered pair for each. So you're looking for the coordinates. What I want you guys to do at the top of the page is draw your 2 triangles so you don't have to keep flipping back and forth between the notes and your homework. So the first one I want you guys to draw is the 45, 45, 90. And these sides will never change. The sides never change on the triangle. It's just the positive or negativity will change. And I shouldn't have drawn it this way. I got to flip it around. Sorry if you guys already drew it. The reason why we want to draw it the other way is because I want to show it to you guys as positive angles and positive sides. If I drew it the other way, there would have been a negative side. Oh my gosh. I can't draw straight. So, I still can't draw straight. Whatever. That's a right angle. Even though my iPad says it's not a right angle, it is. So, in this 45, 45, 90 right triangle, across from the 45s are always going to be radical 2 over 2. The hypotenuse is always 1. So put it at the top of your page because every one of these problems that you're going to be doing on this homework is either going to be the 45, 45, 90 triangle or it's going to be your 30, 60, 90 triangle. Man, I cannot draw. There, that one looks a little bit better. So when you do your 30, 60, 90, we got 30, 60, 90. Across from the 30 is always going to be 1/2. Across from the 60 is going to be radical 3 over 2. And across from the hypotenuse, or the hypotenuse, is always going to be 1. I mean, you're supposed to memorize them, Sierra, but because, I mean, technically everything that you do is going to be at home, you have open notes to do these. If you go to take Math 12 with me or pre-calculus next year, then yes, you're going to have it memorized, but I'm going to show it to you guys with the sine, cosine, and tangent functions. So the way that we're doing it right now is kind of the annoying way, but I just had to show you guys where the numbers came from because it makes more sense for when we go to do our shortcut method. Okay. What we're doing is by hand. Sometimes your calculator will be able to solve these for you. Tabitha, which question was that one? Give me one that has 90 or 180 in it so I can explain it real quick for you, because those ones are actually the easiest ones. I keep clicking into the wrong lesson. Tabitha's question said, hey, what if you get an angle that is either 90 or 180? So Tabitha said, if we're looking at C&E, I'm going to go back to the front page of the notes just to show you guys this circle. And I'm going to write in the angles of 0, 90, 180, and 270. And then I could also put in 360. So let's say that you did all of it out and you got an answer of 90 degrees. Well, you can't draw a triangle that goes to the x-axis for 90 degrees. But if you look at the front page of your notes, I already gave you the coordinate for 90 degrees. If 90 degrees is hitting on this line right here, look at the coordinate that it's pointing to. 90 degrees is really just going to be that 0, 1. If you look at 180 degrees, 180 degrees is just over here. 180 degrees is always going to be represented by -1, 0. 270 is going to be down here. It's going to be represented by 0, -1. And then 0 and 360 is going to be represented by 1, 0. So on the homework, if you get anything with 0, 90, 180, 270, or 360, you can base it off that unit circle right on that front page. Okay? So, lesson went a little bit longer than I wanted to. Sorry, guys. I just wanted to make sure that you guys had all your questions asked. No lesson tomorrow. So if you want to come into Zoom, you still can. I'll send it out and remind. But other than that, do the best you can with the homework. And if you got questions, let me know. Okay? I hope you enjoy the new outro music that my buddy made for me. And other than that, I will catch you guys later. See ya.